Hi, welcome to my talk about single-page applications not only for Java developers. I'm Simon Martinelli and I'd like to talk to you about my favorite web application framework, Vaadin. First, some words about myself. I started my IT career in 1995 as a COBOL developer on IBM mainframe. In year 2000, I moved to Java, and in 2009, I started my own company. I'm working as a freelance developer for many customers, mainly in Switzerland. I'm also a lecturer at the University of Applied Science in Bern. I'm an active member of the Java community. I'm an expert group in Java Batch, Money and Currency, and I'm helping organizing events in Switzerland for the Java user group Switzerland. And last year, I received the Vaadin Community Award. So why do I like Vaadin? Often, companies have to implement data-centric business applications. Usually, these applications have a lot of database tables, but just a few users. But the UI requires some components like a grid with paging, sorting, and filtering. It has forms with data binding where the user enters data. And that's exactly what works very well with Vaadin. Vaadin has a rich component model that you can style with theming and adjust it to the look and feel of your company, for example. If you look at the history, we see that Vaadin already is 20 years old. There are some milestones to mention, for example, version 6. Then Vaadin introduced Google Web Toolkit, so it used Google Web Toolkit to build the code. And in 2019, they moved away from GWT, and now Vaadin is fully web component based and was renamed or branded to Vaadin Flow. That's a complete new architecture. In 2020, TypeScript Vue was introduced. This framework is called Vaadin Fusion, or was now renamed to Hilla, and we will see that in a moment. Currently, we have version 22, and 23 is just about to release. So let's have a look at the Vaadin Flow architecture. Here we can see that we have an application server involved. An application server in terms of Vaadin by default means it's Spring Boot. You can also use Quarkus or any Java EE application server if you prefer. And on the server, you have your user interface code that uses components. So components are Vaadin components in Java, and all these components have a representation as a web component on the client side. You can also use HTML templates if you prefer to have your view in a template. There is also a UI builder that you can use. And you can use theming to style your components with CSS. Then from the user interface code, you can access services in your business logic or repositories of your persistency, or you can call any REST API from another microservice, for example. That's up to you. But your whole programming will stay on the server. So what happens at runtime? At runtime, if someone accesses your application, the web components, templates, and the theming are served to the browser, and from then the browser interacts with the backend. So you have a bidirectional synchronization of the component state from the client to the server and vice versa. And then in that case, you have kind of a single page application running in a browser that accesses your backend. So the benefits of that architecture is you can use a type-safe Java UI component API that uses web components, but you don't need any REST API for the communication because the communication is handled internally of Vaadin, so you don't have to touch this code. Plus, you have a bidirectional data binding, so if the user changes anything on the client, it will be reflected to the server, and if the server changes state on the client, this will be reflected on the client. You can also have push notifications, so you can send events from the backend directly to the browser. If you have a look at some code, we will see more code in a minute. We see a simple view. It's called Hello View. Extends from a vertical layout. Vertical layout is one of many layouts that you can use from Vaadin. And this class is annotated with route. In case of Spring Boot, this means that the route is also a Spring Bean, so you can use a dependency injection in the route. And the route means this view has a path. In that case, the path will be hello, because view is the default suffix and will be removed from the path, so you can access your application, for example, at localhost 8080/hello. Then in the constructor, we use the Java API. If you know Java Swing or any other desktop application framework, then you will be very familiar with such code. So we create a text field, we create a label, we create a button, and the button as a second constructor parameter has a click listener, and there we, if someone clicks the button, we set the label of the text of the label to the greeting. And finally, we add the text field, the label, and the button to the vertical layout. That's it. So it's very easy for a Java developer to get started with Vaadin, because he can use concepts he already may know. Then the second architecture is Vaadin Fusion. As I said, it was renamed to Hilla recently, but the architecture stays the same. So what we have here on the backend, we have so-called endpoints. We will see such an endpoint in a minute. And on the client side, we have a traditional single-page application programming model. So we have an application shell, that's the index.html page, that uses routing, and the routing references the pages or the views that are fully written in TypeScript. So you write your UI code in TypeScript, but you access the Java backend. Now, what's the benefit of Vaadin Fusion in contrast to Angular or React, for example? Hilla, the new name of Vaadin Fusion, integrates Spring Boot Java backend with a reactive TypeScript frontend. So that means you build your UI with the web components, so you use the same web components that you would use with Vaadin Flow, but you have a reactive programming model in the client side. And the biggest difference is you don't need a REST API. So you don't need to create the REST API and client code to access the REST API. The REST API and the client code are generated. And on top of that, Vaadin adds security, so it's not possible to use an endpoint if you don't declare how you can access it. But in contrast to Vaadin Flow, where you have the client state and the server state, and these states are synchronized, Hilla application will be fully stateless. So that means you can scale your backend because it will become fully stateless like you want. So Vaadin Fusion works very well if you have thousands of users and a lot of concurrent requests. Hilla uses lit. Lit is a web component library. Before, Vaadin used Polymer, now it uses lit. And lit is a reactive framework. That means if you change the state, it will be immediately propagated to the UI, and the UI will be rendered. You have a template system, and if you like to know more about lit, just go to lit.dev and you can see some code. Now, let's have a look at the Hilla view. Here we have more or less the same view as before, just now written in TypeScript. And what you can see here is that this view also extends a view. This is a Vaadin TypeScript class, and we have a custom element decorator. For Java developers, decorator is the same as an annotation in Java, more or less. And the custom element defines the name of the web component. We will have a look at the generated code later on when we do the demo. Then we have a name member here, that's some state, and we have a render method. And in this method here, we create the UI based on the Vaadin web component. So we use the Vaadin text field, we use the Vaadin button, we have a value change listener, we have a click listener. The value change listener sets the name that is entered in the text field to an internal name state, and the method say hello shows a notification and with the greeting, for example. So that's how Hilla works. We will see some examples later on. Now, the interesting part of Hilla for a Java developer are the endpoints. An endpoint is a Spring Bean in that case, and the endpoint generates a REST API, plus it also generates the client access code. So that's a very important fact. It's very easy to use the backend from a Hilla client. And as I said, it's secured by default. That means you have to declare who can access the endpoint. We do that with standard security annotations like permit all, so this method will be public available, or we can use rows allowed, or we can also use secured, whatever we need to use. Now the question is, how or when do we use Flow and when do we use Hilla? I would say if I want to build a full stack backend system that's very data-centric with not so much users, then I would go with Flow. Because if I'm a Java developer, it's much easier to create the UI entirely in Java. You don't have to build the REST API, you don't have to build these endpoints that we've seen before from Hilla. You just develop in Java. That's very useful or handy for data-centric business applications. If you want to avoid server state, maybe because you have thousands of users, you have thousands of concurrent requests, and you want to scale the backend system, then you can go with Hilla. Hilla brings a traditional single-page application programming model based on lit, and it also saves you time because you define the endpoints and you don't have to create the REST API and the client access code. Now let's have a look at one of my customer projects. I was called by a customer to help him with his ERP migration because they were using Oracle Forms as the UI framework that creates a desktop application that you have to install on the customer's PC, and they didn't want to do that. They wanted to have a web front end. And first they tried to replace the Oracle Forms with some low-code tool. This didn't turn out so well, and they were looking for a different approach. And interestingly, the low-code framework was generating a Vaadin web UI. So we decided to go with Vaadin and do a prototype. And it turned out that Vaadin works very well exactly in the domain of the customer, because as you can see here, this is a typical data-centric application. So we have here on the left-hand side a table where the user can choose a data record, and this record will then be displayed in a form where the user can change the data and save the data. So this is a traditional data-centric application. If you have a look at the numbers, we see that the ERP system is huge. We have close to 800 forms, close to 2,000 tables, 4,600 procedures and functions in the database, and some user-defined types, but that was not the biggest problem. The biggest problem is that because it's a ERP product, the customers of the ERP product company wants to customize the UI. So how do we do that? We built the UI editor where we see a tree on the left-hand side. This is the component tree, and the customer can adjust like everything, all properties of the component. He can move around the components, and so he can customize how the ERP system will look and behave on the customer's server. Now, currently we don't have a visual representation of the component tree, but we will do that later. But have a look at how this works during runtime. At runtime, the user will access a module, and then we have a framework. I was in charge for building the framework. So that's why I know Vaadin very well, because I had to deal with all the components that we have to create. I had to deal with how data is loaded from the database in the components and stuff like that. So I became kind of a Vaadin expert. And this framework will first look at UI data. So when the user accesses a module, for example, product management or customer management, the UI is generated based on the data in the database, and then the UI will be displayed. We also have some user rights and rights based on the data that must be taken into account when generating the UI. So for exactly these kind of applications, Vaadin is a great fit because it comes with all the components that you use to build such applications. Now that's it from the slides. I like to jump into the code and show you how you can build your own Vaadin application. So how do we create the Vaadin application? The easiest way to start is to go to start.vaadin.com, and there you can select the framework. So you can select the Flow framework, for example, and then you get kind of a theme builder. Here you can add views. So for example, we add a master detail view, then we have a nice table with a form where you can edit the table if we select the data. We can adjust the theme. So for example, we can say we prefer a dark theme or a light theme, and we can adjust the settings. So we can choose the Vaadin version, Java version. We can even define access control directly here inside this UI builder. Once we're finished, we can download a zip file, or we can directly publish our solution to GitHub. I did this, so I have a GitHub repository. It's on github.com/72services/Vaadin introduction. And here inside this project, I have two projects created, a Flow and a Fusion project. And either Flow or Fusion has the exact same UI structure. So we have a Hello World view, a Master Detail view, and an About view. So let's go to the code and check out how this looks like. So here we can see we are in the Flow project, and Maven is used by default from Vaadin. So we have a POM XML, we have a source, main, Java, resources, directory structure that is common for Maven projects, and we also have a front-end folder with a theme. Now let's have a look at the application. Our application class is a Spring Boot application because Vaadin uses Spring Boot. It has a theme annotation. That means this references the folder in front-end themes directory. It's called Flow. Here we can change the look and feel of the application, the look and feel of the components. Then Vaadin is able to generate a progressive web application. That's the annotation here, the PWA, that we can give a name, some offline resources, and this, for example, allows that the user can install the application locally on his computer from the browser. Then here we have some npm packages that are important. The point is that Vaadin on the client side uses npm to build the client, and that's why we also can use npm packages to import other npm packages. For example, here the line awesome is an icon set. Now let's have a look at the view. We've already seen the Hello World view, so let's go to that one. And here we see that the Hello World view has a page title annotation, that we can also have dynamically generated page titles, because often you want to translate your application, so you don't want to have here the static name. Then we have the route annotation. Here in that case, the hello is defined, so the path of our application will be hello, and the layout will be main layout. So every view can have its own layout. Usually you create one layout and all the pages are using the same layout. Often you have more than one. For example, if you have an admin section and a public section, then it may look differently. And what we see here, this Hello World view has a route alias with an empty string, That means this view is also accessible at the root path. Then we have the horizontal layout that we've already seen. We add some margin, then we create the text field, a button, and then on the button we add notification listening. So that means if we look at the browser, that's exactly what we see here with Hello World. And here we can enter a name, say hello, and then Hello Vadin will be displayed. Now, how does this work? To check out how this works, I open the developer tools, and then I can see the HTML code. And here we see a div with a flow container inside. We see the app layout, and inside the app layout we also see a horizontal layout. You can see these are all web components. Web components must have a prefix like flow and Vaadin to distinguish between them and regular HTML components. And in this layout we also will find the text field and the button. So that's what happens here. So this is generated on runtime. Now, if we want to know what Vaadin does, if we hit the Say Hello button, we can go to the network folder. And I've already entered here some text, and let's call Say Hello. And here you see request is executed. The payload of this request is an event, a click event, as we can see here. And the response is a JavaScript JSON structure, and that contains some changes. And if we scroll down here, we see a Vaadin notification, and we also see the text Hello Vaadin. So that means our click on the button took a round trip to the server. On the server, the click listener was executed and returned Hello Vaadin. And if I click on Say Hello again, then we see again that Hello Vaadin is displayed. So that's how Vaadin Flow works. Now let's go back to the code and check out another view. I've created the master detail view, and this one is quite interesting because it shows a lot of concepts of Vaadin. First of all, we see in this time the master detail view just uses a div. We also see that this route has some parameters. So for example, we have the master detail is the path, then we have path variable, sample person ID and action, and this is used to define what should be displayed. So we have also an implementation of a before enter observer, and this will require to implement the before enter method. And in this before enter method we access the route parameters here and extract the person ID, and if this is there we populate the form. So let's go back to the browser and check this out. So this is the master detail. If nothing is in the URL, then we see the list, the form is empty, and if we click on the element, we see that the URL changes, and this will then allow us to enter the data. And if we open this URL in a browser, we see that the state is not preserved, but it selects the data that we have selected before. Now let's go back to the code and check out how the UI is created. We see here that we use a grid. A grid is used to display a table of data. We can the grid has a type sample person, and we have the text fields on the right hand side of the form that are here defined. The grid then has columns. We can set the property names of the columns. This will then automatically render the data. Here we see that something is deprecated. That's the old way to use that with a template renderer. In new Vaadin versions, you would do that with a lit render because it changed from polymer to lit element. And once we have added the columns, we can set the items. And set the items, you can pass here a lambda expression. That's a callback that will be executed. And here we see that we have a sample person service with a method list. And we have a query that is passed to this method. And on this query, we have a page, the page size, and a sort. So that means we get from the query that from the grid all the information that we can use in our list method. And if we have a look at the list method, we see that this method uses a repository and uses the method find all of this repository, and Spring Data JPA provides a pageable, and the pageable is used with the page number and the size to page through the application. That means the data in the UI is loaded lazy. So if we scroll down, the data will be fetched. So there will no single query executed that loads all the data. Let's imagine our table has 1 million records, then this would take forever. Other than that, it creates a paging. So you also can define the initial page size that you want to use, and this will work very well and is exactly what you want to use. Also, sorting works like this, and if you want to have filtering, also that would be possible. Now, after we created the grid, we want to use the data, or we want to edit the data, sorry. So we create a select listener here, and then we populate the data if we have requested the information. So this means if we select a record, the form here on the right-hand side will be populated. And for populating the data, we use a binder. In that case, a bean validation binder. There are various types of binders. Bean validation binder means it uses bean validation. And we'll have a look at sample person. And here we don't see any annotation, but what we can do is we can, for example, add not null annotation from the bean validation package to let Vaadin validate the data. And then we set the instance fields of this class to the binder, so it binds all the components that can be found on this class. And we have some cancel and save button. If you have a save button, we see here that we update the person with the sample person that we have here. If the person is null, then it's a new record. We create a sample person. Other than that, we save it. Here we write the bean. That means the binder writes the data that has been entered back to our application. And then we clear the form and refresh the grid. And populating the data looks like that. We have an editor layout that is created. It's a form layout. Form layout is responsive, so depending on the size, it depends, or it switches the layout. For example, here we have a single column, and then if it gets bigger, it goes to 2 columns, for example. And here we also see how the form is created. We have the components that are created, and these components are added to the layout. And the binder is responsible to set the data to the form. That's how it works. So I hope you get an impression of the Flow framework. Let's move ahead and check out the Fusion framework. We see that the Fusion project has the same structure as the Flow project because it's also Maven based. The difference is if you look at the source main Java folder, we don't see any front-end code. So we see the backend service, the entities, and we see an endpoint. Let's have a look at this sample person endpoint. The sample person endpoint is used to load the data in the grid. And here we see this has an endpoint annotation and it has a security annotation, anonymous allowed. This means that the access without a logged in user is possible. So now let's have a look at the methods. The endpoint uses a service, as we did before with Vaadin Flow, but it has a list, a get, an update, a delete, and a count method. Interestingly, these methods are annotated with non-null. These are Vaadin annotations that tell for the compiler that the TypeScript code is generated accordingly based on these annotations. We also see that the list method takes Pageable as a parameter, so we also have directly paging support from the client. Now let's go to the front-end folder. In the front-end folder we see views, themes, and store. We also see the index HTML, that's the shell. We see an index TS file that uses routing, so it creates a router, sets the router, and in this router we see here the view routes. So we have a hello world view with the context root, we have a hello pass with the hello world view, we have a master detail view, and the about view. And if we have a look at the generated folder, we see there are a lot of generated JavaScript and TypeScript files. But interesting is the sample person endpoint. Let's have a look. Here we see that Vaadin generated a class, a TypeScript class, that provides all the methods that we have on the endpoint. So we have a count, a delete, a get, a list, and an update method. And this uses a client to call the endpoint REST endpoint at the end. Now, if we have a look at the views, start with the Hello World view, then we see this is more or less the same as we had in the Java code. Expect that now this is a web component that can be seen on the custom element. So we have a tag name, Hello World view, and we have to extend the view. View is a class from Fusion that extends some lit classes to provide all the functionality. We have a connected callback. This method is called once the component is added to the DOM. And we have a render method that returns the template. So we can see here we have a Vaadin text field, a Vaadin button, and these are exact the same components that also Vaadin Flow uses. We also have a change listener, for example, on the text field. We have a click listener on the button. So if you want to know how the syntax of this template looks like, you can go to lit.dev and see all the examples about lit element. And then we have the say hello method. So if someone clicks on say hello, the notification will be shown. That means we have exactly the same application. Here again, this time it's the Fusion application. We can say hello, and hello Vaadin will be rendered. Now, this is the easy one because it's straightforward. What's more interesting is the master detail view, because this class is much bigger, but it's also a web component. So we have here a custom element with the name master detail view. And we see here a new concept we can use at query decorator with a selector. So here we select the grid by ID, that we can use the grid in event handlers, for example, from the template. So if we have a template like here, where we define a split layout, in that case, we define a grid, we add the columns, and also we have a form layout here with the first name, the last name, and so on, to edit the data. We also have a save button and a cancel button. And this listeners here, for example, the save, this will refresh the grid. And the grid here clears the selected items and clears the cache, so the data will be reloaded. And that we can use the grid here, we need this query decorator to get access to the grid. We also see a property, that's the grid size. A property is a state that is public, so if we have a look at the generated code in the browser, we would see this property grid size on the master detail view, for example. And then we have a data provider. The data provider is used to access the data. We will see that in a minute. And we have the binder. The binder is used to bind the form data, also again to the components. So here on the grid side, we see that we use this grid provider and we use the grid size. And we have the item changed listener here. That's interesting, where we get the sample person from the event. And if we have an item selected, then the sample person endpoint is used. And here we see how it is used. For example, to get the grid data, it uses list. To get a single value, it uses get. And to get the count, it uses count. So you don't have to care about how this works. So the mechanism how Vaadin Hilla uses the endpoints, calls the endpoints on the backend side is fully transparent for you. You don't have to care about that, and this saves you a lot of time. So if you change the methods on the endpoint, for example, then the generated TypeScript code will be regenerated, and probably because it's TypeScript, the code will not compile because you made some breaking changes there. So this gives you security as well, and also some development speed because you don't have to deal with doing that. Now, if we have the binder as a last element that we want to look at it, we can use the binder to read the sample person that we get back from the endpoint, and this will display the item as well. And if we save it, we do the same. There is a convenience method, it's called submit to. So in the TypeScript world, we can directly pass a method to submit to that will be executed with the binder to update it. And sample person endpoint update just calls the endpoint method update and passes the entity. That's how it works. Yes, that's it from the demo project. To conclude, I hope you have seen that creating a UI with Vaadin Flow, with the Java-based API, makes the life very easy for a Java developer because he can stay in the Java world. He don't have to care about TypeScript code and all the build stuff there. But both frameworks, Flow and Hilla, help you that you don't have to care about the client-server communication. So without caring about client-server communication, you save really a lot of time. As we've seen with Hilla, if the endpoint will be changed, the front-end code will no longer compile, so you know that there's a mismatch between client and server. So for both frameworks means that you can concentrate on building the application, you don't have to care about that. And at the end, in both cases, you get a single deployment. So because we are using Spring Boot, in both cases, the product at the end will be an executable jar that we can run on the server, or we could directly build a Docker image out of it. That's very convenient. So that means what we build with Flow and Hilla are so-called self-contained systems. So that means we are creating small parts, or we can create small parts of the application that are bundled into a single deployment. So that's it from my side. Thank you very much for watching. And if you have questions, you can ask them right in the chat.